So imagine you want to know what the distribution of a population looks like, but you want to examine all of the individuals of that population. So how did you do that? The well, one of the ways to do that is by selecting individuals randomly, meaning you give equal chance of each individual to be selected, and you repeat that multiple times. The point is that even if that works, people may not know about it or may have not been shown that it actually works and they have to believe about it. Or maybe you can wonder how many samples I have to take in order for the sample to be meaningful, to be representative of the population. Should I take 100 samples, 300 samples, 1,000 samples? Well, usually I think the recommended um, size is around 1,000 samples. I think for that's good enough. But I mean, how do you know that's true? I mean, maybe you didn't have the chance to see that why that happens. So in order for that to be shown, I have created a simulation with a computer in which we run an experiment in a made-up population in which we take samples randomly and we compare the distribution of the sample at each time with the distribution of the population. So we are going to run from 0 samples to 5,000 samples. You can see here, for example, that we have the sample number 180, and here we have our population. We have decided to distribute this population evenly between gender, 50% male, 50% female. For example, this is the age distribution, less than 80 years old, 10%, between 18 and 40 years old, 30%. So the green bar is the distribution of the population we wanna know something about. And the sample is the black bar. It's what we know through the sample we have taken. We can see that because we are in the sample number 180, we are making a mistake of around 6% regarding the gender distribution. So here we go with the experiment.